Hello, my name is Sylvia and we are going to do an optimization analysis. We are going to get an optimal portfolio, a diversified portfolio. Let's open a portfolio, the S&P 100 for example. And actually we don't need to go through any of this, any previous steps before. We can immediately calculate the efficient frontier or the construct portfolio. It's up to you. The efficient frontier, this green curve, is actually the supremum of all portfolios that can be created with these 100 securities. What does it mean? We have here 98 securities to be exact, and then we give them different percentage. So here we assume that 100% is our portfolio, and then we'll try all combinations. We give to the first one 3%, and then to each one of them 1%. We give to the first one 30%, to the second one 30%, to the third one 30%, and to the fourth one 10%, and that's another portfolio. And then we give to the first 20 securities in this list, each one of them will get 5%. That's another portfolio. And we'll do all of these combinations, okay? Meaning that we tried all the portfolios that we can create with these 98 securities. For each such portfolio, we get a level of risk and a level of reward, expected return. And then we plot all of these points. This green line is the supremum of all these points. With these 98 securities, we cannot, for example, be at a higher level than this green line. Such portfolio does not exist with this subset of securities. And that is the efficient frontier. Now, each point of this efficient frontier represents one portfolio, okay? At a level of risk that is stated right here, 16%, right here, and at a level of reward that is stated right here, here it's 34%. Each point on this graph represents a security. And for example, the securities that are shown here are the securities that participate in the efficient frontier. Okay? You notice that all of them are performing well, right? Okay. And of course, we could show all of the securities, all of the 98 securities. What happened to all the other ones? It means that all the other ones that are not shown here got a weight of 0. They do not participate in optimal portfolios. Let's show them, for example. Right here. Right here are all the securities, the 98 securities. Some of them did not participate in making up the optimal portfolio. Okay. Now let's go to the construct portfolio. This is the asset allocation. Each point on the efficient frontier represent a portfolio. Okay? You have 100 points actually here. You have 100 portfolios that are represented here. Most of them are concentrated here with not much difference. The tangency portfolio is the most efficient portfolio. What does it mean? It means that it would give us the highest price reward per each unit of risk. The minimum variance portfolio is the portfolio with the least risk. What does it mean? It means that you would notice that actually all of these do not sum up to 100%. So what it tells you is like this. When you have a risk-free of 2%, meaning suppose you can place your money in the bank in a CD and get 2% for it with no risk, 0 risk. 2% per year. Then what it tells you is like this. Invest in these securities, this percentage of your portfolio, and the rest of the money invest in the risk-free asset. For example, put it in the bank in a CD saving. The tangency portfolio is the most efficient one, and it will sum up to 100%. It will give you the most reward for each unit of risk. In this case, expected reward of 30% per year for a level of risk of almost 13%. Actually, we are done. In another tutorial, we'll have a look at the capital asset price and model analysis and the backtesting. Thank you.